Every second, somewhere on Earth, iron is being consumed by an enemy you can't see or stop. It doesn't announce itself. There's no sound, no alarm. Just a slow, patient transformation happening on bridges, ships, and buried pipelines right now. Rust is not decay, it's chemistry. And once you understand how it works, you'll never look at a metal's surface the same way. Iron wants to be iron oxide. That's not a metaphor. At the atomic level, iron is unstable when exposed to oxygen. It's searching for a lower energy state like a ball rolling downhill. Oxygen is the hill. Water is the path that lets the ball roll. Here's what most people miss. Rust doesn't just need oxygen, it needs water. Pure, dry oxygen won't rust iron. You can leave a nail in a completely dry room for a century and it won't change. But add humidity, add rain, add a single drop of moisture, and the chemistry begins. Water acts as an electrolyte. It creates a pathway for electrons to move from the iron to the oxygen. This isn't just sitting there. It's an electrochemical reaction happening in real time. Electrons are flowing, energy is being released, iron is being transformed. The irony is brutal. Iron is one of the most useful metals we've ever found. We built civilizations on it. But the moment we dig it from the ground and expose it to air and water, it's working to return to where it came from. We're fighting a losing battle against thermodynamics. Consider what rust actually is. Iron oxide, the same compound that makes rust-colored soil and red clay. Iron wants to become this. It's not damage, it's a return. The metal we prize is the unstable form. Rust is the stable form. Nature prefers stability. The cost is staggering. Engineers estimate that corrosion costs the global economy around $2 to $3 trillion annually. That's not hyperbole. That's infrastructure failing, pipes breaking, ships sinking, buildings weakening. All because of a chemical reaction we still can't fully stop. We've tried everything: paint, coatings, stainless steel alloys that resist oxidation, cathodic protection where we deliberately corrode a sacrificial metal to protect the iron. We've invented 1,000 workarounds, but we haven't defeated rust, we've only delayed it. Stainless steel doesn't rust because it forms a protective oxide layer, a different kind of oxide that actually shields the metal beneath. It's not that stainless steel avoids oxidation. It's that the oxide it forms is impenetrable. A clever trick, but only a trick. The oldest iron objects we've found are meteorites. Iron from space, billions of years old, untouched by Earth's atmosphere. The moment they landed, the clock started ticking. The moment they were exposed, they began their journey back to iron oxide. There's a ship, the USS Arizona. It sank in Pearl Harbor in 1941. Today, more than 80 years later, it's still rusting. Slow, patient, relentless. The ocean provides an endless supply of water and oxygen. The wreck sits there, molecule by molecule, becoming something else. What's remarkable is that we can see rust. It's visible. It's orange-brown and unmistakable. But the transformation is invisible until it's too late. By the time you see rust, the damage is already deep. The chemistry has been working in silence for months or years. Engineers have a term, corrosion control. It's not corrosion prevention. They know prevention is impossible. The best we can do is slow it down, manage it. Accept that rust will always be there waiting and plan accordingly. In deserts where humidity is almost non-existent, iron objects last far longer. In tropical regions where moisture hangs in the air constantly, rust accelerates dramatically. Geography determines how quickly the invisible architects of rust can work. Every bridge has a lifespan, every pipeline, every steel building. These aren't arbitrary numbers. They're calculated based on how fast rust will consume the structure. Engineers know exactly when the chemistry will likely win. They design with an expiration date in mind. The unseen architects of rust aren't alive. They're not even visible. They're oxygen molecules and water molecules following the laws of thermodynamics, pulling iron back toward its natural state. They're patient. They're relentless. And they've been working since the moment we extracted iron from the earth. We've built our modern world on a metal that nature wants back. We paint it, coat it, protect it, and delay the inevitable. But the chemistry is patient. And somewhere right now, on a bridge near you, on a ship at sea, on a buried pipe in the ground, rust is silently winning. Subscribe to uncover the hidden science in the everyday world around you, because the most fascinating stories are hiding in plain sight.